Friends, welcome to our complex analysis video. In the sequence of complex analysis video, we are discussing the conformal mapping of module 2. Now, in the sequence of conformal mapping of module 2, we have discussed so many topics related to the conformal mapping. In today's lecture, the very short topic, that is the critical points. So, what is the critical points? So, see here. Consider the bilinear transformation. We have already explained in our previous video what is the bilinear transformation. Here we have just taken the bilinear transformation. W equal to T of tau equal to A tau plus B divided by C tau plus D. This is nothing. This is the form of bilinear transformation. Now, when we take the inverse of the result, then tau equal to T inverse W equal to B minus WD divided by CW minus A. This is the inversion of the bilinear transformation. Now see here, this is the bilinear transformation and this is their inverse. The transformation T associate with a unique point of W plane into the Z plane. So what are the conditions? The condition accept the point tau equal to minus D by C. See here, minus D by C. Because C is not equal to 0. When C is not equal to 0, then this is the accepted point of the result associated with when we transform the result with Z plane to W plane. So tau becomes minus D by C when C is not equal to 0. The transformation T inverse associate with a unique point of Z plane to any point of W plane except the point W equal to A divided by C when C is not equal to 0. This is the result. When we talk about the result in terms of W, see this is the result, unique point of Z to W plane. In that case, the W equal to A by C when C is not equal to 0. When we talk about the inverse result, then the tau meaning is minus D by C when C is not equal to 0. So, exceptions of the point of tau equal to minus D by C and W equal to A by C are mapped into the point W equal to infinity and Z equal to infinity respectively as shown in the equations 1 and 2. See here, suppose this is the W equal to A tau plus B divided by C tau plus D. When we differentiate both sides with respect to tau, then this equation becomes the form dW divided by d tau equal to AD minus BC divided by C tau plus D whole square. Now see here, the meaning of dW divided by t tau equal to infinity if tau equal to minus D by C, and when tau equal to infinity, then this result becomes what? 0. So this is the conditions. So the point tau equal to minus D by C and tau equal to infinity are called the critical point of the conformal properties and does not hold the good. So this is the critical point, tau equal to minus D by C and tau equal to infinity is called the critical point of the transformation, bilinear transformation. So friends, this is nothing, this is all about the critical point of the result. So in the sequence of conformal mapping, this is one of the important topic related to the conformal mapping. When we talk about the bilinear transformation, their inversions mapping and their exceptional point are here is the conditions dW divided by d tau equal to infinity when tau equal to minus D by C and 0 when tau equal to infinity. So this is all about the critical points. Friends, in the sequence of conformal mapping, we will discuss in our next video, and the topic of that video is bilinear transformation. So we will discuss this topic in next video. So thank you.